let's create an AI agent using Amazon Bedrock and Elasticsearch that automatically detects cost anomalies, correlates that with the deployment, and send you automatic alert on Slack every single morning without you even touching it. It also provides you the root cause and what actually happened and why the cost is high. It takes the average of previous 7 days to detect that anomaly. And you can also get the current status by talking the agent in plain English. Okay, and I will share you the code, links, and everything in the GitHub repository and everything in the description section down there. So don't worry about it. And let's build this agent. Let's build this end-to-end AI project from scratch, and let's follow along the video till the end. But before that, if you are new here, hello, my name is Piyush, and Cloud and DevOps is what we do all day long. Recently, I've been getting a lot of requests about AI-based projects, so that's what we are doing right now. We are trying to correlate AI with DevOps, with observability, and so on. So this is one important project that you should have in your resume, and that's something that you should be building if you are learning cloud and AI. So yeah, let's get into the video. Alright, so this is the project that we are building. So there will be an AWS Lambda function that is running, and this is actually your cost anomaly agent that will call Amazon Bedrock via Converse API. This Amazon Bedrock will be using Claude Sonnet 4.5. We are using an old model because it helps you save some cost, and we don't need a high level of reasoning for this project, so that's why we are using the Claude Sonnet 4.5, but feel free to use the model of your choice. And then we are using it for reasoning, right? But we are actually restricting it to use max 20 iteration of the reasoning, so like it won't fall into the reasoning loop, and just putting a higher cap to the cost. Then what it will do, it will invokes the Amazon Bedrock to do the reasoning, but then it has to get some data, right, to make that reasoning decisions, to provide some information. So it reads that data from these 3 indices. Okay, so there are 3 indices inside Elastic Cloud. So we'll be using a Elastic Cloud serverless marketplace offering. So we'll be using an Elastic Cloud serverless marketplace offering from AWS, and it has 3 indices that we'll be creating. One for the billing and cost data. From where we get this cost data, we'll be getting it from here, from AWS Cost Explorer, right, via the Cost Explorer API. Now there'll be an agentless agent running via cloud. So this data will be collected by the Elastic Agentless Collector. Okay, so you don't have to provision a separate infra or create another pipeline. So this agent will be responsible for getting the Cost Explorer data via the Cost Explorer API, and then it will put that data inside this indice, which is metrics AWS billing. Okay, so this will be the source of truth for Lambda to analyze the data, to get some historic data and what's going on currently. So it will read that data. It will also read all the deploy events such as CI/CD events. So there is a separate indice for that, and it will write all the audit records inside this cost anomaly audit trail indice. Okay, so these 3 will be the Elastic Cloud serverless indices that it will be using. Once that Bedrock finds anything, okay, once it finds any anomaly by comparing the data with the past 7 days average. So once this Amazon Bedrock once it finds anything that it finds that, okay, so this is not something that is a pattern, past 7-day average is quite less, and today something has happened which could have spiked the cost. So it will analyze it and it will trigger the Slack alert. Okay, so it will post a message in a dedicated channel that, okay, something went wrong, here's the reason, here's what you need to do, and so on, right? So we'll see everything in action. So we'll be setting up everything. Okay, we'll be setting up the Bedrock, we'll be setting up Lambda, we'll be invoking it, we'll be setting up the event bridge schedule. So it's nothing but just a scheduler. It will run the cron job every 8 a.m. Okay, and then we'll be subscribing to the Elastic Cloud serverless, and we'll be creating multiple indices. We'll be interacting with AWS Cost Explorer via this collector, agentless collector. Okay, so yeah, let's start with the demo. Okay, so let's start with our project. I'll be sharing this GitHub repo. Okay, so it will have everything. So there'll be a folder folder called .𝗏 because this project I have created entirely using 𝗏, which is provided by AWS. This is similar to how Claude works. So it will have a spec folder and a steering folder. Okay, it will have MD files. MD files are nothing but the instructions for 𝗏 agents to provision the project, to provision and generate the code, because this project that we are creating, it's heavily AI focused, right? So we have generated the project entirely using 𝗏, which is again provided by AWS. Now it will have different files in the MD format, so there is no hardcore requirement like what naming convention you should be giving. It's like Claude.md and all the files inside Claude directories that you might be using. Okay, so like Claude have Claude.md, so you could have a memory file, you could have a product specification and so on. So this is similar to that. So you can start with the requirement. Okay, requirement is your detailed requirement that you are providing to the agent to configure the code, to generate the project and so on, right? So give it a little context like a background, create some user stories with the acceptance criteria, because without acceptance criteria it will not know that whether the generated code is working or not, right? And then your user stories, like multiple user stories. So break down each of the step into a separate user story. Like first user story for the schedule, which is done by EventBridge. Second user story for the root cause correlation with the deployment. Third is for Slack alert. Fourth is for audit trail. Then reliability and cost guardrails. Okay, so everything has to be in a separate user story in a particular format. Like if you have worked on Jira or any agile project before, so this is the format that a user story use, right? So as a platform engineer, I want to achieve this so that this happens, right? And it will have some acceptance criteria, like without these steps the user story won't be marked as completed. Okay, so this is the requirement.md file. Then we have task.md, which breaks down the user story into separate tasks, okay, into different phases. So phase 1, build the core infrastructure. Phase 2, agent core. Phase 3, tests, and so on, right? I won't spend much time on this because I want to still focus on the actual project implementation. So just wanted to give you an idea if you are new to 𝗏. Okay, and like it is not mandatory to use 𝗏, use whatever you want. I'm just sharing you what I have used. Okay, and then there'll be tech.md, which will have the obviously the tech specification that we are using in the project, like language to use, a host to use, triggers, secrets, right? AI reasoning models that we are using, which region that we are using it for, the data layer, the alerting, everything, right? So that was the 𝗏 part. Now let's move to the actual implementation. So first step, as you can see from our project, we need a Elastic Cloud serverless offering, right? So I'm just gonna go to this link over here, and there is an offer that's been going on. You will get up to $1,000 of Elastic consumption credit for the first 3 months, right? And it is valid from May 4th to November 30th this year. That's their promotion event, and you need to perform these steps to get the credit, right? So subscribe to the Elastic Cloud serverless via cloud offering by November this, and register your offer, then start your trial, activate your billing credit, and use credit for up to 3 months. Okay, so let's go ahead with this. I'm gonna open this in a new tab. Okay, and it will open the AWS Cloud Marketplace offering for me. Okay, you can search from the AWS console as well, but this is also fine. So let's click over here. If we can see, register your offer by filling out the application form within 72 hours of this. Okay, so first let's click over here, view purchasing options. Okay, so let's click over here, try for free. Okay, so that's offer summary, that's your cost after the trial period end. Click over here, okay, and hit subscribe. All right, so it's done. Now click on set up your account. Again, we'll redirect you to cloud.elastic.co. You can log in because it says an AWS marketplace subscription is already associated, which is we just did. So you can log in with that account. Okay, so once you log in, you will see something like this. This was another deployment that I did earlier, so it is showing. But what you need to do is click over here where it says create a serverless project. Okay, now you have multiple options over here. So you have Elasticsearch for observability and for security. What we need is Elastic for observability because it includes everything that we need, including including AIOps, logs, synthetic monitoring, everything, right? So click over here, and then you have to provide your project name. Let's call it my observability project. Keep it default, use the default cloud provider and region, and hit create serverless project. Okay, it will take a couple of minutes, so I'm just gonna pause the recording. Okay, so it says the project is ready. Now click over here, open the project, and now we need a few details from here. Okay, so over here where you see the project, the drop down, click over there and click on manage project, and then it will take you to this UI where you need the application endpoint. So here are all the endpoints for APM, for Elasticsearch, for ingest, and for Kibana. Everything is there. So what we need is Elasticsearch endpoint. So click over here, Elasticsearch, and copy this public endpoint. I'm just gonna save it to my VS Code somewhere so that I don't lose it. So let me just create a new file. I'm gonna delete this file later, but let's just call it Elasticsearch endpoint. Okay, and here's the endpoint. Let's go back. We've copied the endpoint. Now let's go back, and now what we need is the API key. So click over here, settings, and go to access API keys over here and create API key. So give this API key a name. Let's call it cost anomaly agent. And yeah, you can keep everything as default, and click over here, control security privilege, and you can add the code over here, and I'll provide you this code in the repo, so don't worry. What it is saying is, it is saying like we have these two indices, provide that read access to view index metadata, and for this index provide create index privilege. Okay, so over there create API key. Okay, if you don't provide these permission, it will by default create the API key with the elevated permission, which we don't need, right? So here's your API key. Copy this now, and I'm gonna again paste it over here, API key. Okay, let's go back to the next step. So next is to configure the Slack. So I'm just gonna go to api./app, sign into your Slack account, and let me sign in. Okay, let me use this. This is my personal workspace. So what I need to create a new app. Okay, I think let's create it from here. Okay, create a new app, and from scratch give this app a name. Let's call it again cost anomaly agent, and select a workspace and hit create app. Now over here find incoming webhook section, incoming webhooks over here, and activate it. Now add a new webhook. Okay, select a channel. Let's use general channel, but you can dedicatedly create FinOps channel or a separate channel for your alerts. For now, I'm just gonna use general channel. Click allow. Okay, and copy the webhook URL, and you can test it using a curl if you want. So I'm just gonna save this as well. Okay, now let's go to our GitHub repository, and inside this, let's go inside Elastic Cost Explorer. And inside this, where am I currently? I'm inside the root directory. Alright, so let's go over here in the terminal and activate Python virtual environment, Python 3-m venv, and there'll be a venv folder, and then it will create an activate file over here. So next step is to source that file. So source.venv bin activate. Okay, so now we are inside the virtual environment. Now we need to add some shell variables. Okay, so let me just paste the snippet over here so that we can make the changes. Okay, first is your account ID, so it will get the account ID. So let's just paste it like this. Second is your region. I'm gonna use East 1, so let's use this. Third is your Elasticsearch URL, which is what we have already copied. Oops, sorry, I pasted it in the wrong file. So let's just take it from here and not this one. I thought it was a text file. Okay, so this is one. Okay, so let's take Elasticsearch URL from here, and I'm gonna paste it over here, and let's use this. Now Elasticsearch API key, which is over here. Okay, so now we have Elasticsearch super user key. We'll need this for seeding. Why we need it for seeding? Because we'll be injecting some dummy data to do the cost analysis for us. So we'll set this part as well. Okay, so what you can do, you can go back to Elasticsearch where it was. Okay, and create another API key over here, and let's call it es super user, or I'm just gonna call it super user. Okay, and do not apply any restriction on it because we need some extra access for that. Let's just copy the key and go back, paste it over here. Okay, and paste this. Now we need the Slack webhook. Webhook is over here. All right, and that's it. So all the environment variables have been set now. Now what we'll do is we'll create the IAM user. So make sure you are already authenticated with your AWS account. After that, you can just create the IAM user. So this is the user I have created, Elastic Billing Reader. You can create it from the UI as well, but UI changes a lot. So I prefer to use CLI so that you won't see the discrepancy. Then we'll provide the Cost Explorer CloudWatch read permissions. Okay, so I'm just gonna paste the CLI command again. All the commands will be there in the GitHub, so don't worry about it. Plus you can do this from the UI as well if you want. Okay, so there is this username that we have just created. We are creating a policy for that, Elastic Billing Read Only, and here is the policy document with these permissions. Okay, so it is allowing get access on cost and usage, tags, dimension values, and CloudWatch metrics, data list metrics, and so on. Okay, hit enter and the policy will be created for you. Now we need to generate the access keys for this user. Okay, so let's just generate it, save it again safely so that you can use it. I'm just gonna paste it over here in this document. Okay, so we have a key ID and a secret. Okay, I'm gonna clear the screen, and now next is we need to add the observability data inside Elastic. Okay, so let's go over here and go to observability, add data. What we need is cloud data, which is AWS. So click over here and then click on the cloud provider, which is AWS. Now there are all the AWS services. That means there are many ways to ingest data inside AWS. What we need is AWS billing data. So search for AWS billing, click over here. Okay, and then click on add AWS billing. Okay, so now you will see something like this, which will provide you the option to integrate AWS. Okay, so now give this a name, AWS integration. Let's keep it default, it's fine. Description, access keys. Now this access key and secret access key is what you have copied earlier. So let me just copy it from here. This is my access key and access secret. Okay, let's go down and select the agentless. Okay, because we don't need an agent, and click over there, select collection period as, let's use 5 minutes. Okay, let's keep only service, remove AZ instance type and linked account. Let's clear this field as well and click on advanced options. Now inside advanced option, select the add the default region, which is US East 1 in my case. So I'm just gonna provide it. Oh, it's not there. Advanced option. Okay, not here. Advanced option. If you scroll up, there is an advanced options over here. Click over there and enter US East 1 in the default AWS region, because only this region provides the Cost Explorer API. Okay, and I believe that's it. Click on save and continue. After a couple of minutes, you will see something like this. Agentless deployment was successful. Now it is waiting for the incoming data to be ingested and received by Elastic. You will see something like this. Go to integration policies, and over here you will see your integration policy as healthy. If you are facing any issues, or if you find any, if it is in unhealthy status, then you can click on it and this will show you like why it is unhealthy and so on. Right now, let's close this, and now let's check if we have started getting the data or not. So go to discover from the left. Okay, so this is your Kibana UI. Now click on the data view, and we need to create a new data set. So create a new data view. Now you will see a new index pattern over here because we have started getting the data. So this is something that you will see, metrics AWS billing. So it will get you the billing data. So copy that and paste that in the index pattern. Give this a name. Let's call it billing data. Okay, and yeah, let's hit this save data view to Kibana. Okay, now you will see like you can sort it with the billing data which I have selected, and you will see the billing data started streaming over here in Kibana. That's one part. Now, if you look at the diagram that we created, so this part is done, and now we need to create this Amazon Bedrock, and then we'll be configuring the Lambda function. So let's go back to AWS and let's search for Bedrock, Amazon Bedrock. Okay, so when you go to Bedrock, you'll go to this model catalog on the left side, and if you are using it for the first time, it will ask you to enable the model, right? It will ask you a couple of details like how are you using it, like just a use case form. So fill in the description. I will provide that in the GitHub repo as well, so don't worry about it. And yeah, so after that, after 15 minutes or so, your profile, inference profile, will be visible. So to check that, you can go to CLI and execute this command, which is AWS Bedrock list inference profile for that particular region. So there are multiple profiles, but what we need is this one, 𝗏𝗏 Sonnet one. This is what we're going to use. Okay, so our profile is active. Now let's go to the next step, which is secret manager. Okay, now what we'll be creating a couple of secrets for Elastic and for Slack webhook, right? We will not be using the plain credentials, so we'll be creating some secrets. So for that, there'll be these CLI commands that you will run. So it will create AWS secret, this, and we already have the region set. Let me check if these keys, we already like set it earlier, but let me check if it is still valid. Yeah, US East one. Yeah, so this profile will be valid. I can just run these two commands one by one. Okay. The operation failed because secret already exists. Yeah, so I've already created it. Let me do the cleanup quickly. Okay, so let me see it now. Create secret. Okay, so because it's already scheduled for deletion, that's why I cannot create the secret with the same name. So let's just change the name. Instead of cost anomaly agent, let's just use something else. Creates -1. Okay, secret has been created. Now echo elastic ARN. So here's the secret ARN. The second one was Slack webhook. Again, we'll do the same. We'll name it Slack webhook -1. Okay, so this has been created as well. Now we're gonna create IAM role. Okay, so first, because this Lambda function that we'll be creating, this Lambda function should have access to the Bedrock, right? So that's why we need to create the IAM role, attach it to the Lambda, and then we need to provide the permissions to it, right? So we are going to create IAM role, okay, with this name, and effect is this will assume the role. Click enter. Okay, that's done. Now we're gonna attach the policy to it. Done. Now IAM put role policy. Now this will have the details of the access that Lambda should have. So for example, it have Bedrock invoke mode with response stream using the Bedrock Converse API, and then view marketplace subscription, and then secret manager get secret value for both the secrets that we have created. So hit enter, and the policy fail legal parsing. Okay, maybe because it has a double quote, so I'll just remove this. Okay, let me just copy this again. Okay, so this is done. Now the next step is to build the Lambda function. Okay, so again, I'm gonna do a pip install in the same directory. Here is our virtual environment. So I'm just gonna do pip install, and there'll be a requirement.txt. Maybe I'm not in the current directory. Elastic cost agent, and let me just run this again, and I'm gonna source it again. Okay, so let's do a pip install again. I do see requirement.txt over here. I'm not in the correct folder. Okay, so let's do that. Okay, this should install all the dependencies for the Lambda. Okay, and now I'm just gonna do a make zip. Okay, to zip everything, because Lambda has to be uploaded as a zip. And then let's just quickly check the file. It's around 15 MB, so that's good. Now you should wait for 15 minutes, around 15 minutes for the IAM propagation. All right, so the next part is to create the Lambda function. So this is the command I'm going to use: AWS Lambda create function, region, function name, runtime, and like every detail. You can use UI as well if you want. This is what I'm using so that it will be easier for me to share with you in the GitHub repository. Plus UI changes a lot, so I prefer using CLI whenever it is possible. Okay, so here are all the variables like Elastic secret, Slack secret, Bedrock region, and so on, including the model ID, and hit enter. Okay, it's creating the agent. Let's go back. Okay, let's go and quick check if the Lambda has been created or not. So go to Lambda functions and refresh cost anomaly agent. Here is our Lambda function that has been created. Now let's go back, and now we'll be creating the event bridge schedule. Okay, so for that I'm gonna run a couple of commands. Again, it will be there in the GitHub repository. So over here it's an event bridge rule that will set up a cron job to run it, trigger it every morning at 8 a.m. UST. Then we are doing a get function to get some values inside this variable, and then we'll put the targets as the lambda. Okay, so the event bridge rule has been created, and then it says like that's the statement. Okay, everything should be good. You can verify from the event bridge. Let's go and search for event bridge. Okay, so this is the event bridge dashboard, and then you click over here, rules. There are two rules for event pattern, and then there are scheduled rules. Says schedule rule move under the scheduler section. So go over here, or yeah, go over here. Okay, here is a rule which is cost anomaly agent daily. It has a trigger 8 a.m. UST. Here is the cron syntax and so on. Okay, now let's verify everything end to end. First, let's go to lambda and let's try to trigger this. Okay, lambda cost anomaly agent and click on actions. Okay, and then go to test over here. Let's call a test event and event JSON. Let's use it as source equal to manual test. That's it. Hit test. Okay, here is the execution details. It should show you the input token, output tokens, and total tokens, everything. Now let's go and verify this from our Slack. Okay, here's the general message, and yeah, I don't see anything yet. Okay, so let's check this. It says, okay, so after some time, as you can see, the status code is 200. Okay, and it shows that it's been completed successfully, no issues with that. And you can check the logs over here as well. I'm just gonna open the CloudWatch console in a new tab, and you can check your Slack. So in your Slack, you will see that there is an alert generated. Now, it shows a lot of details, and the data is fabricated. That means I seed the data. I did the I did actually enter the dummy data inside my cost explorer so that it gets that data and it will actually find the issues with the cost. Otherwise, I won't be having a lot of cost accumulated in my account. It won't show you the actual anomaly, right? Because I have already optimized my account. But because I've added the data, now it shows that today I am being charged this many dollars, but the average per day for the past 7 days was these dollars, like $532, right? So it detected the anomaly. Okay, something is wrong today, and likely causing is the scheduled auto scaling policy or the reserve instant expiration at month, right? Suggested fix is this, the auto scaling schedule and reserve instant coverage for June, and this will help you with $524 of optimized cost optimization per day. Okay, now you can check the lambda logs as well over here. This should be the latest event. You will see all the iterations that it did, like it called the tool multiple times, find all the different, like it actually called multiple functions one at a time, and then at the end it also called post Slack alert function, so which posted the Slack alert, and also it called write audit, so we can check the audit as well. So what you can do is you can go to Elastic, select your project, and over here you will see dev tools, developers tools on the left corner. Click on that, and there is like some sample queries, right? So just replace that with the get query. So we are doing a get on this index, which is cost anomaly audit, and sorted by the timestamp, and click over this send button. And now you will see that it has a record which says this was the index, here's the ID, that's the timestamp, and we found one anomaly. Slack message was delivered, duration was this second, and every little detail, the status was successful. So it actually wrote it to the audit as well as it triggered the Slack alert, so that you know what the root cause is, you can take the necessary action. So it actually found everything. It actually added the data to the indexes, and now you will have the Slack alert, you will have the cost anomaly audit report and everything. So this is what we have done with the the test lambda invoke, right? But you can schedule it because we also created the event bridge rule. So it will auto trigger the same alert. If it finds any anomaly, it will trigger the same alert at 8 a.m. every day without you doing anything manually, right? So this is an end-to-end agent that we have completed using multiple tools. We have used Kiro to generate the initial product, the code and lambda function code and everything. You can check everything in the GitHub repository. Then we also use Amazon Bedrock that actually calls the lambda function and does the reasoning for you. We have integrated Slack, we have integrated Elasticsearch. Elasticsearch we have used to that collects the data and it stores the data, and then lambda can then search from that data, and based on Bedrock it can do the reasoning and provide you alert in the Slack using the Slab webhook. Okay, so a lot has been done. I'm sure it might be a little confusing, but you should try it out yourself to get the maximum benefit out of it. And all the links will be there in the description, including the GitHub repo, the code, the steps, all the commands that we have used. Everything will be there, so don't worry about it. And that's it. Happy learning. I hope you enjoyed it. I will see you soon with the next one. Thank you so much. Goodbye.